Stripe infrastructure retries webhook deliveries for up to 72 hours if your server does not return a successful status code immediately. This persistent retry logic ensures data consistency but creates a high probability of processing the same transaction multiple times. Network instability often causes identical payloads to arrive repeatedly. This is known as at least once delivery. Your backend must be strictly idempotent, meaning multiple identical requests result in the same system state without duplicate side effects. Every webhook payload contains a unique identifier within the top level of the JavaScript object notation object. This string always starts with the prefix lowercase evt. Use this value as your primary key for deduplication logic. Create a dedicated database table named processed events. Define the event identifier column as a primary key, or apply a unique constraint. This prevents the same event from being inserted twice at the storage layer. Wrap your duplicate check and business logic in a single database transaction. Use the select for update statement to lock the specific event row. This prevents race conditions where two concurrent requests process the same event simultaneously. When a unique constraint violation occurs, your application should catch the exception and return a 200-level status code. Telling Stripe the event was handled prevents unnecessary retries, even if the work was already finished. Every request includes a Stripe signature header. This header contains a timestamp and one or more signatures. Ignoring this header leaves your endpoint vulnerable to replay attacks and unauthorized data injection from malicious actors. The signature header includes a Unix timestamp prefixed with lowercase t. Compare this value against your current server time. Reject any requests where the difference exceeds 300 seconds to mitigate the risk of intercepted packet replay. Your signing secret is a unique key provided in the Stripe dashboard. Never hardcode this value in your source code. Store it as an environment variable or within a dedicated secret management service to keep it secure. To verify the signature, concatenate the timestamp, the period character, and the raw request body. Use the raw byte stream directly from the request. Do not use a parsed or formatted version of the JavaScript object notation. Compute a hash-based message authentication code using the secure hash algorithm 256. Use your signing secret as the key and the concatenated payload as the message. The resulting hash must match the signature in the header. Use a constant time string comparison function to validate the signature. This prevents timing attacks, where an attacker deduces the correct signature by measuring how long your server takes to reject an invalid request.
Webhooks should trigger background jobs rather than executing complex logic inline. Acknowledge the receipt with a 202 accepted status immediately, then push the event to a message queue for heavy processing like fulfillment or invoicing. Using a message queue like Rabbit Message Queue or Amazon Simple Queue service decouples the external request from your internal systems. This architecture handles spikes in traffic and provides built-in retry mechanisms for your own internal failures. Idempotency checks must happen inside the worker process, not just at the web server level. If a worker fails halfway through, the message queue might redeliver the job. Check the database for existing results before starting the task.
Stripe application programming interface versions can change the payload structure. Ensure your webhook handler is pinned to a specific version in the Stripe dashboard to avoid runtime errors when the data schema evolves unexpectedly. Log all incoming webhooks and their processing status. Implement alerting for high failure rates or significant delays in processing. Monitoring the ratio of successful to failed events helps identify issues before they impact your customers. Periodically rotate your signing secrets to maintain security. Stripe supports multiple active signatures during a transition period. Your code should iterate through all signatures in the header and verify if at least one matches the new secret. Use the Stripe command line interface to trigger mock events during development. The listen command forwards webhooks from the Stripe cloud directly to your local host port, allowing you to debug deduplication logic without a public identifier. During testing, manually trigger the same event multiple times using the Stripe command line interface's resend command. Verify that your database only records one entry and that your system does not send duplicate notifications to the user. If your fulfillment service is down, return a 500-level error to Stripe. Stripe will use exponential backoff to retry later. Ensure your internal logic can handle these delayed events without losing state or causing side effects.
In cases where an event was processed but the response failed, your deduplication layer is the safety net. It allows the system to recover gracefully when Stripe retries the delivery by identifying that the work is already complete. Combining signature verification, timestamp validation, and database-backed idempotency creates a robust webhook consumer. These methods ensure that every transaction is processed exactly once, regardless of network conditions or server outages. Consistent monitoring and automated testing are the final steps. By treating webhooks as critical infrastructure, you build e-commerce systems that are resilient, secure, and capable of handling global scale without manual intervention or data loss.
Always enforce the presence of the Stripe signature header in your production environment. Configure your web application firewall to block any requests to your webhook endpoint that lack this specific header to reduce load from bot scans. When logging webhook data for debugging, be careful not to store sensitive customer information in plain text logs. Mask personal details or financial identifiers to remain compliant with data protection regulations while still retaining the event metadata. Your webhook strategy is now complete. Secure with HMAC, validate with timestamps, and deduplicate with database constraints. This triple-layer approach is the industry standard for managing high-volume asynchronous payments reliably.